Welcome to this deep dive explainer. If you are laser focused on prepping for the AWS Certified Generative AI Developer Professional exam, the AIP C01, you have definitely come to the right place. I am super excited to be your guide today. We aren't just going to skim the surface here. We're going to completely unpack and construct a full architectural blueprint for Amazon Bedrock. From the absolute core concepts all the way up to production-level latency optimization, everything we cover is pulled straight from the official docs to help you absolutely crush this exam. Think of this as your personal roadmap to Gen AI on AWS. Let's do this.
Okay, let's dive into the agenda. We are tackling 5 core modules today. First up, we've got the Amazon Bedrock API overview. Then we move to security and IAM permissions. Third is fine-tuning custom AI models. After that, we'll hit RAG and knowledge bases. And finally, we wrap up with AI agents and optimization. We're building this from the ground up, so let's get started.
Starting off with Section 1, the Amazon Bedrock API overview, we're looking at foundation models and core operations.
Now, the biggest game changer with Amazon Bedrock is its serverless nature. It's basically a single, fully managed API that unlocks access to the industry's absolute best foundation models. You aren't locked into just one ecosystem here. For the exam, you need to instantly recognize heavy hitters like Anthropic's Claude for complex reasoning, Amazon's own Titan family for text and embeddings, and Meta's Llama 3. This flexibility means you can always pick the perfect model for the job without ever sweating the underlying server infrastructure. It's all handled for you.
All right, listen up, because this is an absolutely crucial exam tip. AWS loves testing whether you know your API endpoints. There is a sharp, distinct line between them. Anytime you're managing infrastructure, like deploying a custom model or setting up an agent, you're going to use the management endpoints, which are simply Bedrock or Bedrock Agent. But the exact second your application needs to do actual real-time work, like chatting with the user using the Converse or Invoke model commands, your traffic must hit the runtime endpoints. That's Bedrock-runtime or Bedrock-agent-runtime. Burn that distinction into your memory, for sure. Moving right along to Section 2, Security and IAM Permissions. We'll be looking at securing the Bedrock infrastructure.
So the first golden rule of AWS totally applies here. Never ever use the root account. Your developers and apps need to use an IAM user or a role with least privilege access. Now, for the test, you must know the exact names of the AWS managed policies. Need full administrative control? You attach Amazon Bedrock Full Access. What if an auditor just needs to look at configurations without changing anything? Amazon Bedrock Read-Only is what you want. Nailing down these specific policy names will immediately help you eliminate those tricky distractor answers on the test.
Now, what's really interesting about this slide is we are looking at things strictly from a developer's perspective. This is a JSON payload snippet for a Converse API call. See that inference config block? That's where you inject parameters like temperature to control how creative the AI gets. Right below it is guardrail config, which acts as your safety net to block harmful content. And definitely do not gloss over performance config. This is where you actually tell Bedrock to optimize for latency, which is literally a make-or-break feature for real-time apps.
Okay, on to Section 3, Customizing AI Models. We're talking about fine-tuning for custom workloads. Fine-tuning isn't magic. It is a very specific architectural workflow. First, you upload your training data, which has to be formatted as JSON lines of prompt and completion pairs, straight into an S3 bucket. Step 2 is a massive exam trap, so pay close attention. When Bedrock reads that sensitive corporate data, it cannot traverse the public internet. No way. You must use a VPC and AWS private link to keep that traffic securely on the AWS network. Then, you train your custom model, which works with models like Titan, Cohere, and Meta, and once it's done, you just invoke it like any standard model.
But what if your data is constantly changing and fine-tuning just becomes too expensive? That brings us to Section 4, RAG and knowledge bases, which is all about integrating external data.
Retrieval Augmented Generation, or RAG, is an absolute must-know. To build a knowledge base in Bedrock, you first drop your documents into S3. Next, an embedding model, and for the exam, remember this strictly requires Cohere or Amazon Titan. Reads that text and converts it into mathematical vectors. You can even control the vector dimensions. Now, Bedrock needs a place to store these vectors, right? Well, for the exam, know that Amazon's serverless OpenSearch is the default vector store you need to use. So when a user asks the question, Bedrock searches OpenSearch first, grabs the facts, and feeds them to the AI to prevent hallucinations. It's a beautiful system.
And that brings us to our final section, Section 5, AI Agents and Optimization. We're looking at agents and production optimization.
When you push an app to production, you run into scale. So the crucial point here is understanding the difference between ODT and PT. On-demand throughput, or ODT, is your default pay-as-you-go model. But here's the catch. It's restricted by your account-level quotas. If your app goes viral, you might get throttled. That's exactly where provision throughput, or PT, comes to the rescue. With PT, you're essentially buying a dedicated fast lane. You get a guaranteed, elevated rate of tokens that won't be impacted by anyone else using the service. Because let's face it, response time is everything. Bedrock has a neat trick for this. Remember that performance config block we saw earlier? If you pass in latency optimized, you are telling the API to route to hardware that prioritizes speed. It focuses on 3 golden metrics: TTFT, or time to first token, which is how fast the AI starts typing; OTPS, output tokens per second, which is how fast it keeps typing; and E2E, end-to-end latency, the total time for the whole request. Memorize those acronyms. They're going to show up.
Speed is great, but not if the AI is just making things up. That's why we have RAG evaluation jobs. As you can see in this table, evaluation is split into 2 parts. Retrieve only checks your vector store. Did it find the right documents? That's measured by relevance and coverage. On the flip side, retrieve and generate actually grades the final text the AI spits out for correctness, completeness, and logical coherence. And remember, to run this, you have to provide a prompts dataset in S3, so an automated judge model can score your RAG system.
So, to wrap this explainer up, I want to leave you with a classic, provocative, exam-style question. How would you architect a solution to optimize inference latency while maintaining secure multi-agent workflows using custom corporate data? If you've been following along, your brain is probably putting the puzzle pieces together right now. You'd use the Bedrock Agent Runtime API for the agents. You'd lock down the network with AWS Private Link. You'd definitely use serverless OpenSearch for your vector store. And you'd combine the latency-optimized parameter with provision throughput to completely crush any performance bottlenecks. That is exactly how a GenAI professional thinks. I really hope this explainer leaves you feeling confident and ready to ace that certification. Keep building, and I'll catch you in the next one.